Good afternoon. My name is Craig Bossy, and I'm a solutions architect with Amazon Web Services, focusing on Microsoft workloads. I've been working on .NET development and other Microsoft technologies for nearly 18 years now, and I deployed my first application to AWS in 2012.
Hello, everyone. My name is Juan Pablo Melgarejo, and I'm a solutions architect specializing in Microsoft workloads here at AWS. In the past, I used to work as a DevOps consultant before transitioning to the Microsoft workloads organization.
So today, we're going to talk a little bit about using the AWS Toolkit for Azure DevOps to deploy your code to AWS services. And we're going to focus mainly on serverless and specifically .NET-oriented code. We're going to briefly visit some serverless concepts on AWS and then do a whole bunch of demos to help demonstrate the usage of this tool. So first, we're going to talk a little bit about Azure DevOps and the AWS Toolkit for Azure DevOps. So Azure DevOps is pretty much a successor to some of the older SDLC tools on Windows, particularly Team Foundation Server. Team Foundation Server included source control, process management, Scrum boards, that type of thing, work items, as well as build and deploy automation. That's then, when Microsoft hosted it in the cloud, it became Visual Studio Team Services. And then a few years ago, it was rebranded as Azure DevOps. It's a widely adopted platform that many customers and companies and individuals are using. It includes everything that we talked about before, as well as the ability to do things like add extensions and customize the process. For those of you that aren't proficient in Azure DevOps, I just wanted to introduce you to a few key concepts that we're going to be using during this session. So a project in Azure DevOps provides teams with a place to store code, plan and track progress, collaborate on building software, and other sort of things like that. It's like a container for an application or project. A repository is where source code is kept. You can use the popular Git source control format or TFVC, which is Team Foundation Version Control. It's kind of like Subversion. A project has one source control repository by default, but you can create more as needed. A pipeline is a build definition which is defined in YAML. In general, pipelines in Azure DevOps are used to build code, create artifacts, store them, and even in some cases deploy them. A release is a type of pipeline that allows you to deploy the artifacts created by the build pipelines to various environments. Whereas build pipelines might be considered the CI part of CI/CD. These would be more like the CD part of CI/CD. And an artifact is the output of a build pipeline. It's generally a file or files or an archive that the release pipeline will act on to deploy. And then finally, we have variables. These are defined at the pipeline level, and they are just what their name implies. They allow you to not have to hard code different values and allow you to parameterize your process. We'll also see that there are some special variables that we can use with the AWS Toolkit for Azure DevOps in your pipelines. So a little bit about the toolkit itself. The AWS Toolkit for Azure DevOps is no cost to users, and it's open source under the MIT license. And the main thing that the Azure DevOps the AWS Toolkit for Azure DevOps provides is an AWS service connection for providing credentials to tasks and the tasks themselves for deploying and interacting with AWS services. The AWS Toolkit for Azure DevOps is available in the Visual Studio Marketplace, so you can get it from there. If you don't have access to install it, you can request access and have your admin install it for you so that you can use it for your projects. Then, when you go to install it, you'll install it to a particular organization within Azure DevOps. It's available to be installed for not only the cloud-hosted version of Azure DevOps, but also for self-hosted Azure DevOps. So TFS 2017, Update 1 and beyond, and Azure DevOps Server 2019 and later versions. So before we actually talk about deploying anything with tasks to AWS from the AWS Toolkit, it's important to understand the security. So when you're interacting with AWS services, one thing you'll always need to provide is credentials. So with the AWS Toolkit, there are a number of ways of supplying credentials so that these tasks can actually deploy your software to AWS. You can create a service connection and use it directly in your pipeline. This is going to allow you to explicitly supply your IAM credentials that the toolkit can use. You can also use variables in your pipeline. There are well-known variable names that are useful if you're, say, starting pipelines through a different form of automation, and you can set the variables when you actually run the tasks. The tasks, the AWS Toolkit for Azure DevOps tasks will actually pick up the credentials directly from these specific variables. You can also supply environment variables in the build agent environment, and they will be picked up by the tasks when they run. So, if you've done much programming with the AWS SDK for .NET, you'll probably recognize some of these environment variable names as familiar to you for supplying credentials. And finally, if you're hosting your build agent in an EC2 instance in AWS, you can actually just assign a role to that instance. And then the build and deploy processes that are launched by the AWS Toolkit for Azure DevOps will actually use the permissions from the instance profile to interact with AWS services. So when you actually create your service connection in the AWS Toolkit, there's a number of ways that you can actually specify this. So first, you can use static IAM credentials to grant Azure DevOps pipelines permissions to AWS resources. This is really basically the permissions of an IAM user with the appropriate permissions for deploy, for the appropriate permissions to deploy through like an access key and secret key credentials. You can use dynamically generated credentials using the security token service assume role capabilities by providing a role name in the service connection. So the security token service is something you can call to get temporary credentials based on a role that you have rights to assume. This gives you flexibility because the only permissions you need to grant to your users is the ability to use that one role. And then the permissions to deploy are assigned to the role itself. And you can also specify security token service temporary credentials directly through the access key, secret key, and session token. But since the security token service credentials actually are temporary and will expire, it's recommended that if you're going to use this process, that you have an external automated process to update those credentials so that your deployments don't fail because you're trying to use expired credentials. And if you want to create a process to do this, there's an Azure DevOps CLI and REST APIs that you can use to actually update the service connections separately. So what we're going to do now is we're going to take a look at supplying credentials through the service connections. What we do is, in order to create these, we go into our organization and pick the project we want. So I'm going to choose Enterprise Dev Day. I go to Project Settings, and then we're going to choose Service Connections. And within Service Connections, you'll see we already have one called AWS Credentials. And when I edit it, you'll see there's a number of fields that you can fill in. So the access key ID is going to be that access key of the IAM user in AWS that you created. And then you'll need to supply the secret access key for that user. In general, you'll see that both secret access key and session token are grayed out, and they're never going to be returned to the user because those are secret values that are not retrievable. Then, if you want to use a separate role to deploy, you just have to put the ARN of that role in the role to assume box. And then there's some other items here, such as the role session name, external ID, that have to do with assuming roles in the same and other accounts. So once we save our role session, our service connection, we can just save it and it's ready to use. Then if we go over to IAM in our AWS console, this is what the permissions look like on the AWS side of things. So we have a user called Azure DevOps user. And this is the user that had the access key and the secret access key for our credentials. And all we've given them here is permissions to the only permissions they have is to use that role. And so this user is able to get temporary credentials for this role. And if we go to that role, and you'll see that that's where we actually assign permissions for deploying our infrastructure. So here you can see I've assigned power user access and IAM deploy policy. We recommend highly that when you assign permissions to your role or user that's going to be doing deployments, that you really give only the permissions that are necessary to do those tasks and keep the permissions as narrow as possible. So now that we've talked a little about the credentials, let's talk about actually deploying. So the tasks are the other thing that are provided by the Azure DevOps Toolkit. They're the AWS Toolkit for Azure DevOps. These are really the individual units of work that you use to interact with AWS services. You can edit them in YAML in build pipelines, and there's even IntelliSense. And for each task, there's a UI that you can use to fill in some values. And there's generally two different types of tasks in the toolkit. First is the tasks that are specific to deploying things to AWS. And then the other ones are more for like the utility or general purpose tasks that are used for interaction with AWS, but not necessarily to deploy code, but they enhance the experience of using Azure DevOps with AWS. And these tasks are really just templates that specify commands and processes that the build agent will use on your behalf. So taking a look at the different types of tasks that we have. So first we have our deployment tasks. There's a number of things that we can use for use cases to deploy our code to AWS. So for instance, we have a push to ECR, which is our Elastic container registry. So you can push Docker containers for use by other AWS services. We have CloudFormation so that you can actually deploy your infrastructure as code directly from Azure DevOps. We have Code Deploy, which is an AWS service that helps you coordinate complex deployments, doing things like canary builds, blue-green deployments, and so forth. We have several Lambda-oriented tasks, which are you can deploy a single Lambda function, or a .NET Lambda function, or a serverless application with the infrastructure to support it. You can also do things like upload files to S3. Then we have our general purpose tasks. Few things: you can download assets from S3. You can get and set secrets from Secrets Manager, or secrets and configuration from Systems Manager Parameter Store, and you can store them in variables in your pipeline. You can invoke an arbitrary Lambda function, or you can send messages or queue messages in SNS or SQS. We have run command, which is a part of Systems Manager, which allows you to automate interactions with EC2 instances. And then we have some shell script and CLI tasks. So you can either run commands for the AWS CLI, or just run a bash or PowerShell script that has awareness of AWS credentials, so that you can just run whatever you need, whatever custom commands that you need. So Azure DevOps, as I mentioned, uses YAML for describing your build pipelines. The Toolkit's task will automatically generate the YAML based on the GUI inputs that you provide when you define a new task. And in addition, the editor is also aware of the tasks and provides you with IntelliSense, so you can actually type in the values in the editor itself. And if you want to edit an existing task from YAML in the UI, you just hit the little settings link. So we've talked about credentials and we've talked about pipelines. So what we're going to do now is we're going to do a demo and show all of these things in action. All of these things in action bundled together for a deployment pipeline and using some of these tasks. We're going to, in the demo we're going to do, we have some source code, which is just a .NET 6 Lambda function. And our pipeline is going to read a value from Systems Manager Parameter Store, and store it in a variable. And then we're going to deploy our .NET Lambda function out to AWS. Then we're going to use our pipeline to invoke that Lambda function, and we're going to use the value from that parameter as the argument to that Lambda function. Then the return value we're going to store in a separate output. So by using these AWS Toolkit for Azure DevOps tasks, we can deploy and interact with AWS in multiple ways in a single pipeline. So let's get started. First thing I'm going to do is I'm going to go to the repository for our Lambda function. It's just called simple Lambda. And as you can see, we just have a Lambda function that all it does is capitalize some text. It's just kind of a plain one. So we're going to deploy this out to AWS. But one thing I also want to show you first is if we go to Systems Manager, I talked about that parameter. If I go to Parameter Store, I have this parameter called simple Lambda demo input, and it just says the value, welcome to Enterprise Dev Day. So we're going to read that value into a variable. So we're going to go into pipelines, and I'm going to go into a folder here called simple Lambda, and I'm going to create a new pipeline. And for the repo, I'm going to use Azure Repo, and I'm going to use that one I just showed you. We're going to create a starter pipeline, which is really just the minimal you need to get started. So we're going to start. I'm going to make a few changes here. First, I'm going to change the trigger. And the trigger is what actually makes this pipeline start. So we're just going to say none. So we have to start it manually. So it won't start automatically. I'm going to change the pool. I have an EC2 instance that I'm using as a build agent, so I'm going to set that as the where this build is going to run. Then I mentioned we're going to have a variable, so I'm going to supply a variable directly to the pipeline, and this variable is going to be called data. Then I'm going to delete the steps that are in there, and I'm going to go in and let's start adding some of these steps from the AWS Toolkit. So first thing we're going to do, I said we're going to get a value from Systems Manager. So we're going to have SSM get parameter. So we're going to supply our credentials, and we're going to, for our region, we're going to use Ohio. And we're going to just get a value for a single parameter, and that parameter's name is simple lambda demo input. And then what we're going to do is we're going to use a custom name. So when you use this, it can either create variables based on the parameter name, or you can just read it into a parameter that, or a variable that you've already named, and we already have data. So I'm going to use a custom name and call it data. So now we've got that. I'm going to then, in the interest of time, I've already got the other steps kind of done for us. First things first is we have a lambda.NET Core deploy demo, or lambda.NET Core deploy, and this is to deploy that function. And as you see, we specify the project and some other information like the function name that will dictate how it's deployed to AWS. Then, for the task, I'm going to create a Lambda invoke function. And so again, we have credentials and all that. And so we're going to invoke that function that we just created. And for the payload, we're going to take the data that we got from Systems Manager and supply it to the Lambda function. And we're going to invoke it synchronously so we get a return value back. Then, finally, we're going to set up that parameter in Systems Manager, and we're going to create a new parameter called output, and it's going to be a string parameter, and we're going to just pass the value of that of the return value of our Lambda, which went into the variable called data. So at this point, we have our 4-step pipeline, and we're going to save. And this is going to run for us. So I'm going to open up the job, and what's going to happen is that you'll see it's going to check out our code. It just got our parameter. It's going to deploy that Lambda function. And once that's in, and you'll see while we're going here, it uses some of the, under the hood, it uses some of those AWS tools like the .NET Lambda tool to make it happen. So it uses familiar mechanisms for deployment that you've probably already used. And then when it's done, it looks like it succeeded. I'm going to go over to Systems Manager. And all of a sudden, there's a new parameter there called simple lambda demo output. And you'll see here, it has capitalized our value. So we did the round trip from AWS in just a matter of minutes. We built a pipeline to interact with AWS in Azure DevOps. So now that we've kind of got the basics, we're going to go into a little bit about serverless on AWS. So when we talk about serverless computing, we're generally describing applications in which the user or the customer is not really responsible for maintaining underlying infrastructure, and resources are only allocated as needed. On AWS, this really relates to a number of services and even architectural patterns. First, a key component of serverless on AWS is compute. The main components of compute are AWS Lambda, which is function as a service, and AWS Fargate, which is the serverless container runtime. The serverless ecosystem on AWS also includes many other services that enable you to build your applications. This includes services related to domains like messaging, data storage, and even task coordination. And here on our screen, we can see a whole bunch of other services that are commonly used in serverless applications on AWS. And because AWS manages the underlying infrastructure, you're able to take, that we as AWS are able to take care of scaling and high availability of these services without really requiring any architectural changes on your part. Serverless architectures are frequently event-driven and rely on messaging for asynchronous processing of those events. And because serverless architectures can take advantage of multiple different components, infrastructure as code is generally useful to help coordinate your applications. So when we talk about .NET serverless on AWS, there are several forms that you might see. First is the classic serverless. Separate Lambda function definitions are for each feature, including processing a certain type of message, routes for APIs, and that type of thing. This has the advantage of a simpler, more decoupled coding model and is really ideal for handling these event-driven architectures. We also have something that you see frequently when talking about serverless ASP.NET on AWS, in which you can package and run the entire ASP.NET Core runtime on AWS as a single Lambda deployment. In this case, you get the advantage of the entire ASP.NET framework. You get pipelines, middleware, and so forth, as well as the scalability and high availability of Lambda. However, just a caveat is that the ASP.NET Core startup time may play a factor in your app, and an application built this way can start to take on the characteristics of a monolith, which may actually be what you're trying to avoid altogether. So the serverless application model is something used and created by AWS specifically for the creation, definition, and deployment of serverless applications on AWS. The infrastructure as code aspect of SAM is a templating system, which is essentially a superset of CloudFormation and includes constructs that not only allow you to deploy common serverless artifacts more simply, but it also helps to model the interaction between them with convenient shorthands. Then we have our SAM command line interface tool. The SAM CLI tool gives you the power you need to package your application for deployment, deploy it, upload code artifacts, and you can also do things like run your Lambda functions in an AWS-like environment on your local machine. And when you're using SAM with .NET, it also will help to automate the building and packaging of your Lambda function code for deploy with the serverless application. So we're about to do a couple of demos next. And in these demos, we're generally trying to follow the best practice for pipelines to show you. So this is what a typical deployment is going to look like in Azure DevOps. So first, a build pipeline will be triggered by, say, a check-in of source code. The build tasks take that code, transform it, and store it as an artifact. Then a release pipeline reads one or more of these artifacts and uses them to run the appropriate jobs to deploy those artifacts to the proper environment, in our case, on AWS. And you may have multiple stages in a single release, and use things like gates between them. For instance, you might have a UAT or a test environment that once the tests have passed, they will run in a UAT environment. Or you may have human approval between these different stages. So now I'm going to hand it back over to Juan to actually do our first couple of demos.
Thank you, Greg. Let's now move on to the demos. Here are the three ones that we will be showing you for the remaining of this presentation. The first, we will first walk you through a single-page application using ASP.NET Core Web API and an Angular frontend. There will also be a demo on AppRunner, which is a fully managed container application service. And last but not least, Greg will show you a serverless application model deployment. The first part of the single page application is going to be our backend, our ASP.NET Core 6 minimal web API. We will be using the AWS Lambda.NET Core task provided in the AWS Toolkit for Azure DevOps. This task will deploy an API gateway plus the Lambda function that contains the API. When we make calls to the API, the gateway is going to route those requests to the Lambda function. As for the front end, it's going to be Angular. It's not .NET directly, but it is something that we often see for SPAs. First, we will grab the code from the repo and generate the artifact built in the Angular code. By using the S3 upload task in the Azure DevOps Toolkit, it will be deployed to an S3 bucket. And for faster serving of the content, we will be using Amazon CDN CloudFront. Once the artifact is in the S3 bucket, we'll need to create a CloudFront invalidation for the content to be updated on all the edge locations. Let's now move over to Azure DevOps so that we can show you how this works. First of all, we are going to go to the repo, which is EDD backend. Here we have the code for our ASP.NET Core 6 minimal web API. And for the purpose of this demo, we're just going to return a hello from Lambda message. And if we go to the website, this is the basic Angular website with returning hello from AWS Lambda. This is coming straight from the backend. So I'm going to modify by adding some text to here so that it deploys while I continue with the presentation. Now I'm going to go ahead and show you what the release pipeline for the application looks like. We're going to organize it by folder so that we can easily see where it is. And here it's the deploy backend one. So here we can see all the previous run, and we can see that there's one which is currently in progress because I just triggered it by doing that comment. So if we click edit, we're going to be able to see the pipeline. Here in the artifacts, we see the main artifact we have, which is coming straight from the source code repo. And we also have a stage for deploying to AWS. So if we click here, we are able to see the tasks we have. In this case, we're using the AWS Lambda.NET Core task. And for configuring this, we will be using the credentials that Craig showed earlier in his demo. We are going to also specify region. As for the deployment type, in this case, it's going to be a serverless application because we wanted to deploy the API gateway and all the other required configurations. Here, as the path for the Lambda project, is just going to be our artifact. Since it's using CloudFormation, our infrastructure as code tool in the backend, we need to give it a stack name so that we can go to CloudFormation and reference if we need to. And we are also going to use an S3 bucket where the artifacts will be stored in S3. In the advanced configuration, we also need to specify a template. In this case, it's just the serverless.template that is generated automatically when we create the project from the AWS Toolkit for Visual Studio. So by now, the pipeline should have finished. And if we go here and reload, we will see how this message has been changed. Now, let's see how the front-end deployment works. If we go to repos and choose EDD frontend in this case, here we have our Angular code in which I won't go into much detail. If we go to pipelines and organize it by folders, here for the SPA, we have the build frontend pipeline, and we're going to go ahead and edit it. So what is being done in this task is that we are installing the tools that we require, we are building our application, and we are copying and generating and publishing the artifacts to Azure DevOps. Once the artifacts are published, we're going to go to releases, organize it by folder, and choose deploy frontend. So if we click edit here, we can see the artifact that was shown before. And then we also have a stage for deploying to S3. And in here, we have a job and 2 tasks. So those 2 tasks, the first one is going to be the S3 upload. So by using the Amazon S3 upload task, we are going to be uploading the artifact, the compiled Angular code, into the bucket that's called Angular Frontend EDD. Then, since we are also using CloudFront, the CDN, we need to invalidate the cache so that it is updated on all the edge locations. So for that, we are going to be using the AWS CLI task, in which we can provide all the AWS CLI commands So in this case, we will be using the CloudFront command. We will be creating an invalidation, and we are going to be specifying the distribution ID and the paths we want to invalidate. In this case, it's going to be the whole application. So if we create a release and we go into the release, we are going to be able to see the logs. And right now the agent is getting ready, but if we refresh, it is going to quickly initialize, and then we will see how it downloads the artifact that is generated by the build pipeline. It's going to upload it to S3, and then last, it's going to invalidate the cache. So once this is over, the new front end will be deployed to our AWS account. So now I'm going to show you how to do an app runner deployment. How an app runner deployment looks like. So first of all, we have the source code, and we are going to run a Docker build command, which is going to build our Docker image, the Docker image for our application. And by using the Amazon ECR push task, we are going to push that application image into Amazon's ECR repository. Then the deployment is going to actually be done by the app runner service, which is going to detect the change in the repository, and it's going to grab the latest image and redeploy all the application. So if we go back to Azure DevOps and we go into pipelines, here we have the app runner pipeline, which we can go inside and edit. So here, the first thing we will be doing will be building the actual Docker image. And once that is done, we are going to push that image to ECR. And in here, we can see that we have not specified an AWS region, and we are using variables here. The reason why there's no region is because of what Craig mentioned in an earlier slide. It's because it's using one of the AWS.region variables. So that is going to detect it, and it's going to plug that in. And we're also using other variables for our code. So if we run this pipeline, we can go ahead and go inside the job and see how this is building our pipeline. So here it's building our API, and it's pushing the image to ECR. And once it is done, we can go to the AWS Management Console, into App Runner, and we can see how the deployment is right now in progress as it's being deployed. And now I'll switch it over to Craig to continue with the demo of the SAM application.
So all of the examples that we've done so far have been actually somewhat trivial. So for our final demo, I want to show you something with a slightly larger amount of complexity. This is a model of a SAM application, which is that serverless application framework that I mentioned to you before. The application here actually uses AWS step functions to coordinate the conversion of text in a PDF document into an MP3 file using some of the AWS AI/ML services, in particular Textract for reading the text out off the PDF, and Poly, Amazon Poly, for transcribing or for changing that text into speech. This architecture also includes 6 individual .NET 6 Lambda functions as the compute that actually do some of the work of the application itself. And then there's an API gateway that is used to be able to retrieve the finished file. There's also a DynamoDB table for storing metadata and some SNS topics and EventBridge rules for message sending. And this is the basic outline of what we're going to do in our build or our release pipeline. First, we have a single repository with the source code, and it has the SAM template in it, the step function definition, and all the .NET code. We're going to use the SAM CLI to build the artifact. And with SAM, what it does is it processes your template and also invokes the .NET Lambda tools to create the compiled Lambda code for deployment to Lambda. And this particular part is triggered by CI, or continuous integration, when we check in code. Then we'll use the AWS CLI or the AWS Bash shell to run our SAM deploy task. By parameterizing our command, we can actually deploy the same serverless artifact to multiple different environments. And then between each of these stages, we have a gate to require manual approval before moving on to the next deploy. So let's get into our demo. So this a SAM project is basically going to have our template, and this SAM template defines our Lambda functions. It defines all of these other resources as code that we're going to use to deploy our serverless application. We also have a state machine.asl.yaml file to define our step function. And then in our source directory, here's the source code for those 6 Lambda functions that I mentioned that are going to perform various functions. And as you see, they have code that calls other AWS services and processes data. So first thing we're going to do is go to a pipeline. And we already have a pipeline set up for this called serverless step function. And in the serverless step function, all we're going to be doing is creating an artifact that we're going to deploy. So what we need to, and because there's no specific serverless application model task in the Azure, the AWS Toolkit for Azure DevOps, what we're going to do is, as a part of our pipeline, we're going to install the SAM command line interface. So here we're just downloading it from GitHub, and we'll do an installation. Then we're going to perform, using that, we're going to do a SAM build. And this is actually just a regular command line because there's no AWS interaction with this. This is just a local operation that builds and packages those artifacts. Then what we're going to do is we're going to publish the artifacts that we're going to be using in our release pipeline. And I can just run that right now. And you'll see that this job is going to download everything and do a build and publish our artifact. While we're waiting to do that, I'm going to show you a couple of other things. First of all, we have a library. Library is a way that you can create groups of variables that you can use in your pipelines. So for our pipeline, we are going to deploy to 3 different environments. So we have 3 different groups of variables. One for our dev environment, which has this AWS region, which we mentioned earlier, the bucket that you're using to deploy your assets to, the name of the stack, and the environment. And you can see here, so for production, we are deploying to a different region, we have a different bucket, that sort of thing. So this way we can manage all of our variables for the different stages in groups. We're going to go to our step function deploy release. First of all, here's our release pipeline. You can see there's that artifact, which contains our SAM template and the compiled code and all the assets we're going to deploy. Then we have 3 different stages. So we're going to deploy to dev first. And then once dev is done, we can actually, we have people that need to approve the move to the next stage and the stage after that. So we can actually stop partway into our pipeline and do our testing and so forth. So beyond that, and we talked about variables before. So here's where our variable groups that I showed you a minute ago are actually mapped to the different stages. So for this, we're supplying our region for our deployment through that AWS.region variable, and all those other ones are going to be automatically mapped. Then let's look at our different tasks. So for each task, is ultimately going to look pretty much the same. First, we're going to install our .NET Lambda tools onto the build agent, and that's because that's needed by SAM to actually deploy our application. Then we're going to install the AWS SAM CLI, and that's similar to what we did in our build pipeline. And then we're going to use an AWS shell script and using those credentials, and we're going to actually run the SAM deploy command. And as you can see here, the SAM deploy command is actually parameterized so that all the values that might actually change are supplied through those variables that we mentioned. And you'll see that stage, prod, and dev are all basically the same. So you might say, why would we need to install AWS SAM again? Because one thing to remember is that the testing cycle can take hours, days, or maybe even weeks. So that between the stages, we might actually end up using a different build agent, and so the tools may not be there. So we'll just deploy them every single time, or we'll just install them every single time. So again, the key is the SAM deploy. What we're going to do now is we're going to deploy this by creating a release. So we're just going to do the default. And what's going to happen is we'll go to this release. So what this has done is you'll see it's gotten that artifact that we just produced. And now our build agent is downloading the artifact. So there's a whole bunch of stuff there. It's going to install those .NET Lambda tools. Now it's installing our SAM CLI. Now it's going to do the SAM deploy. And so the SAM deploy is where it's actually going to take all of those artifacts and deploy your template. It's going to deploy your Lambda code and everything there. So as you can see now that it's complete. And the reason that it went so quickly is because I'd actually already deployed it earlier and there was no changes to it. But I want to be able to show you the second stage. So first of all, we'll go over to CloudFormation and show you what actually got deployed. So our serverless applications are deployed through CloudFormation. So we have this serverless text-to-speech dev, which is the name of our stack. And it deployed all of these resources. And you can see for any of these, when you do the deploy, you can see the output from those tools. So seeing that there was no changes. In our CloudFormation, if we wanted to, this is where we could actually do some testing, where we could actually upload a file and watch how this whole thing works. So for the sake of this demo, I'm actually just going to go back to the pipeline and show you the final part. So here we have a SAM the deploy to the staging environment, and notice that it's stopped. So now we could go in, do that testing I just mentioned, but I'm going to say I approve because testing was successful. And that now our other person, Juan, is going to go, or I can override this. Okay, so now we can deploy our serverless application to another environment using the exact same artifacts that we did previously. So now that we've seen deploying a number of different types of serverless applications to AWS using the AWS Toolkit for Azure DevOps, the next thing really is to be able to install it on your own environment and do some testing to deploy your own serverless applications. And here I've got some resources that you can look at for user guide and the various documentation for this, as well as the GitHub repo where you can go see the source code for this yourself. So I want to thank you very much for coming to this talk, and hope you were able to actually get a better understanding of how, by using your existing Azure DevOps installation, you can actually deploy your serverless applications or serverless.NET applications to AWS. Thank you very much.